My name is Marcus Cahee. I teach in Iberia Parish and I work at General High School. The content of today's lesson is in 7th grade math using Eureka Math. The lesson objective is that students will be able to use area models to write products, sums as products, and products as sums. Prior to this lesson, students did a previous lesson with using sums as products as sums and sums as products as a beginning lesson to prepare for the lesson that was taught today. The lesson connects to the overall goals of expressions and equations as one of the main cluster items for 7th grade math. Information about the students in our class: we do have 21 students. 20 were present on the day of the taping. The students are students who have struggled with math concepts in the past. They were grouped together in that classroom, and they are students who will all take the LEAP 2025 test. These students have some difficulty with math in different ways, but they're all students who can and will learn. So, adaptations that have been made: we have the class for a longer period of time, so we span out the lessons within that class to adapt for those students. We also work on remedial skills to help build and scaffold to the lessons that we are working on at the present time. All right, y'all, we're on lesson 4, page 22, S22. We're on lesson 4, S22. Yesterday we started talking about writing products as sums and sums as products. So today we're going to continue the conversation with that, but I want you to do a few things first. When your page is turned to that, you got 2 minutes to complete, to write equivalent expressions using the distributive property. I want y'all to do A through, all right, let's quickly check those. For A, 2 and in parentheses, x plus 5. What y'all got?
2x plus 10. No parentheses.
2x plus what?
2x plus 10.
2x plus 10. Remember, we're distributing. 2x plus 10. So, somebody want to tackle the second one? B? Come on.
3x plus 12.
3x plus 12. I think you're right. Third one. We need to volunteer Cahee.
6x plus 6.
Very good. And D, the fourth one. Go ahead, Will. 7x minus 21. Good. Thank you for trying to do the one with the subtraction. I know the subtraction one is the one that gives everyone a little bit of trouble. Same thing you're doing for addition, you're just doing it for subtraction. Same thing for those. Okay. Now, you're gonna have 2 minutes to write them by going backwards. We went forward. We went from backwards to forwards. We got getting rid of the parentheses. Now we're going backwards. So we're gonna have to have what is it? The parentheses. So you raising your hand for E? E. Tamara?
5 parentheses x plus 6.
5 in parentheses, x plus 6, good. Somebody good, somebody good. F. Somebody beat me already. Somebody want to take an educated guess at it? F. Window.
8 parentheses x plus 1.
8 in parentheses, x plus 1. G. Which is lazy.
3 parentheses x minus 4.
3 in parentheses, x minus agenda. The ICANN is that I can use an area model to write products as sums and sums as products. No.
So I would demonstrate
Demonstrate how to use the area to write
products.
products as sums and sum as brackets.
Very good. Travis. Louisa.
Exercise one.
Demai. And your assessment will be your exit ticket. So, coming back to the board, what happens when you go backwards to find an equivalent expression for what happened when you did it for E, F, G, and H? What do y'all think happened? 72t plus 8, 72t plus 8. What y'all think is our common factor? Yes, John. 8 what?
T. 80 T.
Do we have t in both of them? No. So what is our common factor? You say 8. So if I divide 8 times what gives me 72?
9.
9. I have to bring down my t. 8 times what gives me 8?
1.
So t plus 1. That's what. D and E are yours. Give y'all about 4 minutes. I'll give y'all about 4. Everybody stand up. Stand up with your whiteboard. Everybody stand up. For the answer. If before the parentheses, you don't have a 3, sit down. If you don't have a 3, sit down. Now those of y'all with a 3. What's next? What's next? What's next? 41. If you don't have 48Q, sit down. (48Q minus 5). So how many I got right? You see yours? Rectangular arrays. So we'll work on the rectangular arrays. Maybe having the boxes may show y'all a different strategy, a different way to work it out. Excuse me. So, looking at example 2. It says 2x, then it says 12y, and it says 8. What number do we have in common for all of those? 2, huh? 2x, 12y, 8. 12 can be divided by what? What number can we have on the outside? What's the lowest number that we have right here? 2. Can 2 go into 12?
Yes.
Can 2 go into 8?
Yes.
That's our first number, 2. 2 times what is 2x?
2 times 1.
2 times
2 times
x. 2 times what is 12?
2 times 6y.
6 and a y. 2 times what is 8?
4.
Just like that. But let me show you right under. You see how we have it in the rectangular array? This is the same as 2, and in parentheses, x plus 6y plus 4. This is the same thing as this. By show of hands, who likes this method? So y'all like the rectangular arrays, because y'all can see them. Cool. Now y'all just have to now get the correlation from this to this, so they're all alike. Since y'all like that one, the same way that we did it, do exercise 2. Let's check it right quick. 3, 2, 1. Let's show 'em. Good. I'm not seeing one wrong answer yet. Good. So y'all do understand the rectangular arrays a lot better. So we'll work a little bit more on that. All right, let's break this one down. 2 times 6. 12. G plus 20 times 6. 120. 120. T. Good, your scholar. 6 times. Now remember, this is a negative.
18.
So where does that negative go? Right here. Negative 18. That's the second way. Each person plays 6 rounds of golf for 20 tickets with a discount of $3. We talked about discount before. Second one, the total cost is equal to 12 games of golf, 120 tickets, and $18 off. There are 2 different ways to say it. Hopefully tomorrow we'll get to writing it that way. For right now, clear y'all desks. Give y'all exit ticket. Y'all only have 2 cards.
Students, at the end of the lesson, the objectives were met because the students went through the I do, we do, and you do, which is the gradual release model, which was set with the objective in mind. At the end of the lesson, they completed an exit ticket, which is a formative assessment, which told everything that they learned that day. And what they did was they had 2 questions, and they need to go back and answer those 2 questions on what was taught today. So that will then tell me if the students need more help, more assistance on today's objective, or if they've mastered it and we can move on. In retrospect, next time, what I may do is give a little bit more time to the lesson so that we can expand upon what we already know and get into a few more things. Students seem as though they like the rectangular array model, so I would like to expand on that, because if the students are more comfortable with something, then we can take that and move it and expand on it to where they will achieve more success.